In this video, we're going to use the addition method to solve systems of equations, two linear equations, where one of them is going to be, we'll do one where there's going to be no solution, and then one where there's going to be infinitely many solutions. If you're looking for the one where it has one solution, there is a video also on that. Okay, so, and then that other video also explains these steps. So the first step is to pick a variable you want to cancel. Now it really doesn't matter in this case, and I guess let's pick the x. So let's just pick x. Step 2, multiply the equations by a number so that the variable you want to cancel has the same coefficient with opposite signs. Alright then, so let me rewrite the system. Choose a different color. So that was 4x minus y equals 8, and negative x plus 2y equals negative 5. Okay, so what do we, let's see. All right, so we're picking x. We want to cancel x. So let's see what we can do. I want a 4 and negative 8 to become the same number, and I'm looking for the least common multiple between 4 and 8, and that is 8. Okay. Now one has to be positive and one has to be negative. Well, if you can see, one of them already is negative, one is already positive, so we're in good shape. So what do I have to multiply 4 by to get to 8? All right, and then let's multiply by, well, 2. So multiply by 2. So that's going to give me 8x. Remember to multiply everything in that equation by 2. So minus 2y equals 16. And then what are we going to multiply negative 8 by to get to negative 8? Well, you don't have to actually write anything in here, but we're going to multiply by 1. Alright, so then 2y times 1 is 2y, and negative 5 times 1 is negative 5. Okay, but I've satisfied step 2. I want to cancel x. The numbers in front of x are the same, but opposite signs, so we're good to go. Let's move on to step 3, where I'm going to add the equations together. So 8x minus 8x is 0x. Negative 2y plus 2y is 0y. And 16 minus 5 is 11. Okay, well, in this case, what I wanted to do was I wanted to try to solve for y, because my goal was to cancel x's. But notice what happened to the y. It's also a 0. Okay, both of these cancel. Okay, but I'm not going to cancel them right now. I'm just going to leave it like this. And I'm going to ask you a question. What could you plug in for x and y so that you equal 11? Okay, and this happened in the substitution method too, but there is no x and y that will work. Because no matter what you plug in for x and y, it's going to get you 0 on the left-hand side, and the right-hand side's 11. So there's no solution. All right, so there's no reason to go on to step 4, and then there's definitely no reason to go on to step 5. Okay, so that's an example of no solution. Let's go ahead and try one with infinitely many solutions. Okay, so next example, I want to solve the system 2x minus 3y equals 8, negative 4x plus 6y equals negative 16. All right, so let's pick a variable to cancel. I think in the last example we picked x, so let's go ahead and pick y. All right, step 2, I want to multiply the equations by a number so that the variable you want to cancel has the same coefficient, opposite signs. Okay, so let me rewrite the system right here. So 2x minus 3y equals 8. All right, now I wanted to cancel y. So I need y's to have the same number in front with opposite signs. Now 1 is already negative, 1 is already positive, so far so good. And I need to change a 3 and 6 into the same number, which is the least common multiple. and that's going to be 6. The least common multiple of 3 and 6 is 6. So what I'm going to do is I'm going to multiply the first equation by 2. So let's see what we get. That's going to give us 4x minus 6y equals 16. Now this one, all right, it's already a 6y. Again, I needed to have the same number opposite signs. Well, I already have a positive 6y, so I just need to multiply by a positive 1, which means you don't change anything. So that's a negative 4x, and over here that's a negative 16. So step 4, add the equations together. So when I add them, you get 4x minus 4x, that's 0x, minus 6y plus 6y is 0y, and then 16 minus 16 is 0. Okay. All right, so this is a little bit different than the no solution, because no matter what you plug in for x and y, the left-hand side is going to give you 0. Well, what is the right-hand side? It's 0. Yay! Basically what this says is that any pair in x and y that's on the line, or basically any solution to one, will be a solution to the other, because this is always true. Okay, so again, there's no reason to do step 4 because I'm not solving for any variables, and there's no reason to do step 5. So what I'm going to write is infinitely many solutions. So that's what this means when this happens. Infinitely many. All right, but again, what that doesn't mean any pair of x and y, like 2 comma 14. I have no idea if that's going to work, but it probably won't. But just because it says infinitely many solutions doesn't mean any point will work. It just means that every point on the line will work. So every point on the line, I'll just say, is a solution. And why is that? Because infinitely many solutions, what that meant was that they were the same line. And if they were the same line, and a solution is where they intersect each other, they're the same line. They intersect at every single point, because again, they are the same line. All right, so that's using the addition method on no solutions and infinitely many solutions.